Topic 4.3 Gas Laws. Boyle's Law. Boyle's Law states that the pressure P of a fixed mass of gas is inversely proportional to its volume V under constant temperature condition. For the Boyle's law to be applied, two conditions has to be satisfied. That is, mass should be fixed, temperature should be constant. Under those two conditions, pressure P of a gas is inversely proportional to the volume V. This relationship can be written down as follows. P is proportional to reciprocal of V. Introducing a proportionality constant, P equals K times 1 over V. PV equals K. This is the mathematical form of Boyle's law. The same relationship can be written as this. The relationship PV equals K can be graphically represented as follows. The graph of P against V is a rectangular hyperbola. The graph of P against 1 over V is a straight line through origin. Here comes the experiment. Determination of the atmospheric pressure using coil tip. Charles' law. Charles' law states that the volume V of a fixed mass of gas is directly proportional to its temperature T under constant pressure condition. In Charles' law, also there are two conditions. One is mass should be fixed. The other one is pressure should be constant. Under these two conditions, volume V of a gas is directly proportional to its temperature T. The Charles' law can be written down as follows. V is proportional to T. Introducing a proportionality constant, V equals KT. V over T equals K is the equation form of Charles' law. The same equation can be written down as this as well. The graphical representation of Charles' law will be as follows. The graphical representation of Charles' law is like this. If the temperature scale is in degrees of Celsius, the x-intercept will be minus 273.15. Or if the temperature scale is in Kelvin, the graph will be a straight line through origin. Here comes the experiment. Investigation of relationship between volume and temperature at constant pressure. Pressure law. Pressure law states that the pressure P of a fixed mass of gas is directly proportional to its temperature T under constant volume condition. In this law, the two conditions are mass should be fixed and volume should be constant. Under these two conditions, pressure P of a gas is directly proportional to its temperature T. Pressure law can be mathematically written down as follows. P is proportional to T. P equals Kt, where K is the proportionality constant. P over T equals K is the mathematical form of pressure law. The same law can be written down as this as well. Here comes the experiment. Investigation of relationship between pressure and temperature at constant volume. Ideal gas equation. Let's imagine we have a fixed mass of confined gas under pressure P1, volume V1 and temperature T1. Under constant temperature conditions, if we change the pressure to P2 and volume to V dash, according to Boyle's law, say equation 1. Now the second system under constant pressure conditions, if we convert volume V dash into V2 and temperature T1 into T2, according to Charles' law, say equation 2. Now combining the equations 1 and 2, we end up with this relationship. We can extend this relationship as this, and this is called the combined gas equation. As per Avogadro's law, we can deduce for an ideal gas that K equals proportional to N, the number of moles, and introducing a proportionality constant R, we can write K equals Rn, where R is called the universal gas constant. Therefore, we can write the combined gas equation for an ideal gas as this. And we can rewrite the same equation as this. And this is the common form of ideal gas equation. Dalton's law of partial pressure. What is partial pressure? In a mixture of gases, each constituent gas has a partial pressure, which is the notional pressure of that constituent gas if it alone occupied the entire volume of the original mixture at the same temperature. Dalton's law of partial pressure states that imagine we have a mixture of gases A, B, and C in a volume V, and the total pressure of the system is P. If we put that amount of gas A in this mixture only, in a same volume V alone, the pressure of gas A is the partial pressure PA. If we put the same amount of gas B in same volume V, the pressure exerted by gas B is the partial pressure PB. If we put the same amount of gas C in same volume V, the pressure exerted by gas C is the partial pressure PC. Dalton's law of partial pressure states that the total pressure of the mixture of gases is the sum of the partial pressures of its components. That is, P equals PA plus PB plus PC. This can be extended to any number of gases within the mixture.